many questions in these exams have to do with ideal gases. Again, as I said in the previous questions, unfortunately for you, or fortunately for you, if this doesn't address you, you need to know the, the basics, basic ideas theory of what an ideal gas is and ideal gas equation and everything. And I'm assuming you do. And if you don't, go, take 15 minutes, learn about it, and then come back. Anyway, for an ideal gas, what I have is this equation. Um, Question 56, we have, uh, yeah, this equation tells us that when we have, um, just a second, yeah, when we have a container and the container contains gas molecules of a certain type, it can be mixed, it's fine, and we have a specific number of moles, which is the basically the number of molecules, but in different units. We have the gas constant, which is a constant. We have the temperature of the gas. We have the volume, and we have the pressure. Uh, Plugging everything in this equation just is a correct, gives us a correct term. These will be equal to these for an ideal gas. An ideal gas is something you need to learn about. And now in the question, they tell us an ideal gas is a container placed on a thermostat at temperature T and occupies volume V and pressure P. What the thermostat thing, whatever means, is that we have something here that keeps, I don't know, it's an oven or whatever, I don't know what, with a regulated temperature. So then the gas cannot change its temperature. It always stays on the same temperature. Not to explain exactly how this happens now, but yeah, just this is what we have. And now if you notice, and this happens a lot in these questions, it's very repeatable. So this became constant. R is initially a constant, it's just a number, and N is a number of moles, which in these questions and in like I think 99% of the questions does not change. Um, so And now they ask us if the volume occupied by the gas is tripled while keeping the temperature constant, then I can elaborately calculate and show you how, but I think it's some kind of a waste of time because this is supposed to be very intuitive for you. So what I would do is that I will just tell you that like the new volume of the gas needs to be 3V, but we can't change the right side of the equation. So something needs to happen to the pressure. So the pressure needs to be divided by 3 or multiplied by 1/3 in order to stay the same. So the volume goes up, we have a lot of more space in the container, and the pressure just drops, it goes down. And this is the answer, right? You have V becomes 3V, so P becomes P over 3, which is exactly what I wrote down. I don't think it's complicated, so hopefully you're fine with it. And let's continue to the next question.